Welcome to math class today, 8th grade. As an early Christmas present to you, Mr. Shane is going to walk through each and every problem that is on your test. You simply need to follow along, use your mathematical skill to calculate what Mr. Shane asks you to calculate, and do the test with him. Let's begin. Number 1, which is the better buy? 3 pounds of tomatoes for $2.85 or 5 pounds for $4.65. When we're calculating the best price here, we want to find the unit price, which means you're going to take into account how much the item costs per pound to find the price per pound. So you've got two scenarios here, 3 pounds for $2.85. So I'm going to say that it's $2.85 divided by 3. I get the price per pound when I divide that. Or I take 5 pounds and I'm dividing $4.65 divided by 5 lbs. So I set up my two division problems here, and then I'm going to make the division happen between each of those. 285 divided by 3 is 95 cents a pound, and then 465 divided by 5 is 93 cents a pound. Therefore, this one is larger, meaning that the cheaper one is the better buy. So 5 pounds at 465 is the better buy. I could write that out and spell it like this: 465 for 5 lbs, 5 pounds is the better purchase. Number 2, Mary wants to buy a bike for $290. She already has $110. If her job pays $15 per hour, how many more hours will she have to work to earn the rest of the money? Well, it gives us the total, and it gives us the rate at which she's paid. It says she makes $15 per hour. X is going to be the variable that represents hours. So I'm going to multiply 15 times the hours that she works and add that to what she already has saved up. Do you give me my equation? 15x plus 110 equals 290. Well, how do I figure out how many hours she needs to work then by this equation? Use opposite operations. I'm going to subtract 110 from this side, subtract 110 from this side. My new equation is going to look like this. 15x equals 290 minus 110. 0 and 0 is 0, 9 and 1 is 8, 2 and 1 is 1. So 15x equals 180. How many hours she works at $15 an hour to make $180? I would divide by 15, divide by 15. How many times does 180 or 15 go into 180? Or 180 divided by 15 equals 12. That's going to be in terms of hours. Number 3. The spinner is spun twice. Make a tree diagram to show the possible outcomes. What is the probability of spinning 2 both times? You see we have the option of 1, 2, or 3 in our first spin. So with that, I'm going to write out the 3 options. I can get a 1, I can get a 2, I can get a 3. And then from the second spin, I can get a 1, a 2, or a 3. I could get a 1, a 2, or a 3 if I got a 2 on my first spin, and I could get a 1, a 2, or a 3 if I got 3 on my first spin. So if I spun it once, I got 1, 2, or 3. I spun it again, I got 1, 2, 3, 1, 2, 3, 1, 2, 3. These are all the possible outcomes. This is the total. We're looking for the probability of 2 and 2. So we're going to follow this pathway right here. How many of those are there out of the total? The total would be 1, 2, 3 options, 4, 5, 6, 7, 8, 9, and I get 1 out of 9 of those total possibilities. So I get 1/9. Number 4, describe the shape of the graph that represents the following situation. A ball is thrown up into the air, then falls to the ground. The graph relates time to the ball's distance from Earth. So again, we have here our graph shown out. We are measuring, it says, time and distance as the x and y axis. If you throw the ball, over the course of time, it's going to travel away from Earth, but eventually, because of gravity, it's going to pull it right back down to Earth. Kind of makes an upside down U. Number 5, simplify the expression x to the negative third over y to the third. Here you've got negative numbers in your exponents. Anytime you have negative numbers in your exponents, you know that it can be positive if it's moved to the opposite location, either in the denominator or in the numerator. Here you've got a negative in the numerator, so we know that it is positive in the denominator. Therefore, 1 is going to remain in the numerator because we're going to move this whole thing down here, and then we're going to have x to the third positive and y to the third, which remains positive in that denominator portion. Number 6, I've got the expression here, negative 5.76 minus negative 1.61 plus 0.97 plus negative 4.26. How would I come to finding this answer? What I like to do is to make sure that if I have subtraction, I can turn it into addition by saying adding the opposite, and then I put my positives together and my negatives together. So here I've got negative 5.76 minus negative 1.61. So I can say that that's actually adding the opposite here. Two negatives make a positive. And then I can put together these two numbers because they're both positives, and then these two can go together because they're negatives. In this case, I would say, what is 1.61 plus 9.7? 0.97. 7 and 1 is 8. 6 and 9 is 5. Carry the 1 is 2. I got 2.58 as a positive value. I've got negative 5.76 and negative 4.26. I can put those together because same sign sum, keep the same sign. It's going to give me a negative. 6 and 6 is 2. Carry the 1. 1 and 7 is 8 and 2 is 10. Carry the 1. 1 and 5 is 6 and 4 is 10. I get negative 10.02. Now I've got two different signs, so different to subtract. Here's what I would have to do. 10.02 minus 2.58 with addition and subtraction. I got to line up my decimals. I get 2 minus 8, that's going to cancel, borrow, borrow, borrow. 1 becomes 0, 0 becomes 10, that becomes a 9. To borrow to this 10, that becomes a 9, to become a 12. 12 minus 8 is 4. 9 minus 5 is 4. 9 minus 2 is 7. And because I had a larger number that was negative, my overall answer is going to be negative. Number 7. Mrs. Quinn is buying square tiles to cover her kitchen floor. The floor measures 10 feet by 15 feet. Each side of the tile is 2.5 inches. So let's just draw this out so that you can see this in a diagram. So I get 2.5 inches by 2.5 inches. If I'm trying to find the area of one of those tiles, 2.5 times 2.5 equals 6.25. That's for one tile. If Mrs. Quinn buys 3,450 tiles, are there enough tiles to cover the floor? Well, let's take that area of one tile, multiply by how many she has, times 3,450, 6.25 times 3,450 equals 21,562.5. That's inches squared, right? Now we want to know if 10 feet by 15 feet, the overall size of this rectangular shaped room, can be covered with that much square footage in the overall tiles that she has. So it gives us a conversion rate here between square feet and square inches. And then it tells us to divide the area of the floor by the area of one tile, use inches squared. So the first thing I need to do is to convert the area of the room into square inches and then divide those to see if I have enough. So what I would do is multiply 10 times 15. I have 150 square feet, but now I need to change that into square inches. To do that, I would use a conversion rate, which is 150 feet multiplied by my conversion rate for one of those. This would be feet squared, and I would have 1 square foot here and 144 square inches, and I got to do that twice. Or sorry, no, that's 12 to 1, which is 144. You just do it once. You've got 150 times 144 equals 21,600 square inches in the actual room. Does she have enough tile? Well, if this is what the tile that she has covers, and this is the size of the room, you'd say this is smaller than this amount. So there are not enough tiles. Now the other portion here that says divide the area of the floor by the area of one tile. If you took the area of the floor in terms of 150 times 144, which is 21,600, and you divided by 6.25, you'd come up with 3,456 tiles. That means she is just a few short in this case. She needs 3,456 3,456. She has 3,450. So she's 6 tiles short in terms of covering that entire thing. Number 8, identify the property illustrated. Here you've got 4 times 11 times 9, 11 times 4 times 9, and you've got the order that's changing. The associative property is not used here because it's the same numbers that are being associated with each other in terms of what's inside the parentheses. Here you've got 4 times 11, then you've got 11 times 4. What property is that that allows you to identify something that has moved positions or changed the order? Anytime we're talking about movement, we're talking about commuting, so that's the commutative property. And then you're multiplying here, so we would say of multiplication. Number 9, write 6 times x in words in 2 different ways. So I just read it for you, 6 times x, and then you could probably say 6 multiplied by x or the product of 6 and x. You can write that in. Thanks for listening. Number 10, graph the equation y equals negative x using a table. Decide whether the graph represents a function and whether it is a linear or non-linear function. So let's put this together. We got y equals negative x, and I'm going to use this wonderful bar right between number 9 and 10 as my portion. It says for x, try negative 2, negative 1, 0, 1, and 2. I'm going to plug those values in and see what I get as an answer here. So negative 2 is plugged in. What that would look like is this. Y equals negative 2 and then negative x. 2 negatives would make that positive, so that's going to turn into a positive. Negative 1, 2 negatives would make that positive, so that's a positive. 0 would make it 0. 1 would make it negative 1, and 2 would make it negative 2. So if I graph this, I would have negative 2, positive 2, point right there. Negative 1, positive 1, point right there. 0, 0 right through the origin. Positive 1, negative 1, and positive 2, negative 2 to create the line that goes like this in this negative slope or downward direction. It looks linear in the vertical line test. Anywhere you would draw a line goes through at one time. So we would say that the graph is linear and is a function. Graph does represent a linear function. On the back side, number 11, the first truck in a convoy will carry 12 tons of dirt while each additional truck will carry 8 tons of dirt. Write a rule to model the situation. Then use the rule to find out how many tons of dirt can be carried by 7 trucks. Well, here we've got our arithmetic sequence that tells you what's in the first value and then what is the common difference between each additional one, and tells you, well, if I'm given any number in this sequence, can I find what that number represents? We can. It says how many would be carried by 7. So to fill this in appropriately, we're first going to say that, well, the first truck can carry 12 tons because that's term 1, that's A1, and then each additional truck can carry 8 tons. So the common difference, it's going to go up by 8 each time, goes into this value right here. And you would say that this is n minus 1 to complete your arithmetic sequence. And now, what is the value when this n value equals 7? If I plug in 7 for this, I get 7 minus 1. 7 minus 1 is 6. 6 times 8 is 48. And 48 plus 12 is going to give me a total of 60 tons. Number 12, graph the order pair negative 2, 3. First number tells me which way to go on the x-axis, negative 2, up 3. I'm going to be right there. Number 13, find the x and y intercepts for 2x plus 3y. What I would do here is plug in a 0 for the opposite value to find the x-intercept and for the y-intercept. So for the x, I plug in 0 for y. That would give me the equation 2x equals 18, and I plug in a 0 for the x. If I'm trying to find the y, I would get the equation 3y equals 18, and now I can solve for x and y. Divide by 2, x equals 9. Divide by 3, y equals 6. There's my x and y intercept. Number 14, 0.27 of 45 is what number? Of means multiply, so I'm going to multiply these two numbers together. If I'm multiplying by pen and paper, for example, 27 times 45, I don't necessarily need the decimal in there at this point. I can just multiply. What's 5 times 7? 35. Carry the 3. 5 times 2 is 10, and 3 is 13. 0, 4 and 7 is 28. Bring the 8. Carry the 2. 4 and 2 is 8, and 2 is 10. Add those together. 5 and 0. 3 and 8 is 11. carry the 1. 1 and 1 is 2, and 1 is 121, or 12.5. In this case, because I've got decimals, I need to move the decimal from this location, 1, 2 spaces, to there, which would be 12.15. 15. Solve 3/4 x equals 6 for x. Well, to do so, you need to get x all by itself. It's multiplied by 3/4, so I would multiply by the reciprocal to get rid of 3/4. So 4/3, 4/3, what this looks like would be 4 over 3 times 6 over 1. Numerator times numerator, denominator times denominator. You have to check, can you cancel anything before you multiply? You can. The 3 and the 6 have common terms. So how many times does 3 go into 3? That would turn into a 1. How many times does 3 go into 6? That would turn into 2, reducing that. 4 times 2 is 2. 1 times 1 is, 4 times 2 is 8. 1 times 1 is 1. This would be 8 over 1, or equal to 8. Number 16. Solve 3b minus 8 equals 7b minus 2 minus 4b. For b, justify each step. Here we're trying to get b by itself. To get b by itself, I'm going to eliminate other items, or combine like terms in this case. So I've got 3b minus 8, 7b minus 2 minus 4b. These two b's in the same side of the equation can be combined. 7 minus 4 is going to give me a total of 3b here. What I would write in my thinking is combine like terms. Next, I have some property of equality, kind of gives me a hint, in which I'm going to try and put those terms together. And it looks like here I've got 3b minus something, so it's probably the subtraction property of equality, which I got 3b minus 8, 3b minus 2. I'm going to say that this is 3b here, and it's minus 3b, and what you do to one side you do to the other, so those 3b's would cancel on this side, and you'd be canceling them on this side, so you'd get an answer of negative 8 and negative 2. Negative 8 equals negative 2. No, it does not. That is a false statement, so it's not true. This is never true. Therefore, there is no solution. In 17, you've got the expression 2a plus 4 times 3a plus 2 equals 50. Justify each step. In the first example, it has 2a plus a plus blank. Well, when you have parentheses here, you're using the distributive property. And you'd multiply 4 times 3a, which would give you 12a, and 4 times 2, which would give you 8. Then you're going to combine like terms, which you do 2 plus 12, which is 14, plus 8. Now you've got the subtraction property of equality, because 14a, 8 minus 8, you're getting rid of the 8 on this side, and you're going to subtract 8 from the other side. So you've got the sub property of equality. 50 minus 8 is going to give you 42. So in this example, you have the answer of 14a multiplied by something, and then you're going to do that same to the other side. In this case, that answer of 52 minus 8 goes here, 42, and you've got 14a here, and now you're multiplying something to get rid of the 14. You could use the division property of equality, but they're using the multiplication property of equality here, and they're multiplying by what would be the reciprocal of that, or the fraction of that. So of 14, it would be 1/14, and then 42, it would be 1/14. They're doing the multiplication property. So you get the problem that looks like this: 42 times 1 over 1 times 14. Is there anything that's common between those in terms of what you could reduce in that example? 42 times 1 is 1, 1 times 14 is 1, so you get 42 over 14. Do those numbers, are they divisible? Well, how many times does 14 go into 14? 1. How many times does 14 go into 42? 42 would be 14, plus 14 is 28, plus 14 is 42, so that would be 3 times as your overall answer. 18. Estimate the value of the square root of 77 to the nearest integer. Think of your perfect squares. You've got 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81. So you're between 8 times 8 and 9 times 9. You're probably closer to 9 as your overall value, because 9 times 9 is 81. The square root of 77 is closest to 9 times 9, 81, square root of 81. 19. Evaluate p times 3p minus 2q minus pq for p equals 1/2 and q equals 1/4. First thing I'm going to do is write this out in the complete new form with those substituted numbers in for the variables. So p is 1/2 on the outside. multiplied by 3 times 1/2 on the inside minus 2q. Q is 1/4 minus, which would be 1/2 times 1/4. Here's what your final or the initial expression looks like once you've substituted. Now you can go through and solve inside of the parentheses first and then outside the parentheses afterwards. So here you've got 3 times 1/2, which is going to give you 3/2. Here you've got 2 times 1/4, which is going to give you 2/4. That's inside the parentheses. That's all multiplied by 1/2. So here, if I were to subtract this, I have to have like terms. So I'm just going to double this. This becomes 4 if this becomes 6. So you get 6 minus 2, which is going to give me 4/4, which is equal to 1. 1/2 times 4/4 is going to give me 1 times 4, and 2 times 4 is 8. So I get 4/8 in this example. And then I'm subtracting that from what's outside the parentheses here. 1/2 times 1/4. 1 times 1 was 1. 2 times 4 is 8. So that's 1/8. 1/4 minus 1/8 is going to give me a total of 3/8. For number 20, it says solve for n. 3n plus 2m minus 6 equals 4m plus n. Use the inverse operations to isolate the variable. So to get n by itself, I need to first subtract 2m, add 6. I would subtract 2m, add 6 to this side. So 4m minus 2m is going to give me 2m plus 6. And on this side, I'm going to subtract n. So on this end, I subtract n. I'm going to get 2n equals 2m plus 6. And divide by 2, divide by 2. These 2's would cancel, so you get 1m plus 3. And that wraps up what is your test for 7A. What I'd like to wish you is a Merry Christmas. If you've watched this video, guess what? You get a 100% on your math test. God's blessings.